Before the war changed everything, before steel was rationed and factories retooled for military production, there was a golden decade when American farms saw machines most people will never know existed. Today, we're counting down the 10 rarest harvesters out of the 1930s, machines so scarce, so revolutionary, and so extraordinary that finding one today is like discovering buried treasure in a forgotten barn. These weren't just farm equipment. They were engineering dreams built during the hardest decade America ever faced, proof that innovation never sleeps, even when the economy collapses. Number 10, the 1934 Alice Chalmers Model 60 all-crop harvester. The Depression was crushing rural America when Alice Chalmers took a gamble that seemed almost reckless. They built a harvester that could handle wheat, oats, barley, soybeans, clover seed, and even rice, all with the same machine. The Model 60 all-crop wasn't just versatile, it was survival equipment for farmers who couldn't afford specialized machinery for every crop they planted. Announced in 1934, this harvester featured a unique rubber-mounted cylinder that reduced grain damage and increased threshing efficiency by nearly 20% compared to rigid-mount competitors. The machine stretched 12 feet wide at the header and weighed just under 4,000 pounds when empty, light enough to work in soft soil without excessive compaction. Power came from an Alice Chalmers 4-cylinder engine displacing 201 cubic inches, producing roughly 28 horsepower at 1,100 RPM, or revolutions per minute. That doesn't sound like much today, but in 1934, it was enough to pull the machine through fields at speeds up to 3 miles per hour, while maintaining consistent cylinder speed for proper threshing. The all-crop used a unique pneumatic delivery system that lifted grain into a 12-bushel hopper without the aggressive augers that damaged kernels in competing designs. Farmers could adjust cutting height from 4 inches to 36 inches without stopping the machine, a feature that saved hours during harvest when time meant everything. The cab was open, exposing the operator to dust, heat, and the relentless noise of machinery. But visibility was exceptional, critical when working near irrigation ditches or fence lines that could catch and damage the header. Alice Chalmers painted these machines in their signature Persian orange, a color chosen specifically because it remained visible through thick dust clouds that could blind operators and other machines. The paint itself was a special formulation that resisted fading under brutal sun exposure, and decades later, surviving machines still show traces of that distinctive hue beneath layers of rust and time. Only an estimated 350 units were produced in 1934 before design changes came the following year, and fewer than a dozen are known to survive today in barns and collections. Most were worked until they literally fell apart, then cannibalized for parts to keep newer machines running through the war years, when replacement parts became impossible to find. Finding a complete Model 60 today means discovering a machine that somehow escaped the scrap drives, the parts raiders, and the simple passage of time that claimed so many Depression-era machines. The Model 60 represented something profound during those dark years. The idea that innovation didn't stop just because times were hard, that engineering could still solve problems even when money had disappeared. Number 9, the 1937 John Deere. Number 9, experimental pull-type combine. John Deere never officially sold this machine, which makes every surviving example a piece of contraband history that shouldn't exist but does. The number 9 was an experimental pull-type combine designed in 1937 at the Deere factory in East Moline, Illinois, as a testbed for revolutionary ideas that wouldn't reach production models until after the war ended and prosperity returned. Engineers wanted to solve the biggest problem plaguing combines of that era: grain loss that cut into already thin profit margins. Traditional machines left as much as 15% of the crop in the field through improper separation or cylinder damage that shattered kernels. The number 9 attacked this problem with an adjustable, concave clearance system that could be changed on the fly without stopping, plus a secondary cleaning shoe that reprocessed tailings automatically, capturing grain that other machines would have scattered across the stubble. The machine used a 6-cylinder Hercules engine, producing 42 horsepower from 298 cubic inches, mounted transversely to save space and improve weight distribution. The engine choice was unusual. Most manufacturers use their own power plants to maintain vertical integration, but Deere selected Hercules for their exceptional reliability and fuel efficiency, qualities that mattered when gasoline cost money farmers didn't have. The cutting platform measured 14 feet across and featured a canvas conveyor system that was gentler on grain than the aggressive chain and slat augers used elsewhere. John Deere engineers equipped this prototype with a grain tank capacity of 200 bushels, enormous for a pole-type design where weight distribution was critical, and a hydraulic unloading system that emptied the tank in under 90 seconds, using pressurized fluid instead of mechanical augers. The real innovation was the suspension, coil springs between the chassis and axle that smoothed the ride and kept the threshing cylinder level even on rolling terrain that would shake other machines apart. This prevented surging that wasted fuel and damaged grain through inconsistent feeding. The number 9 weighed 5,800 pounds and required a tractor producing at least 30 drawbar horsepower to pull it effectively through varying field conditions. Operators reported that the machine handled beautifully behind a Deere Model A or Model B, tracking straight even in crosswinds that pushed lighter combines off course and into standing grain. John Deere tested approximately 20 units across farms in Iowa, Kansas, and Nebraska during the 1937 and 1938 harvest seasons, monitoring performance and gathering feedback from farmers who understood they were testing the future. Farmers loved them, praising the reduced grain loss and smooth operation. But the company decided the technology was too expensive for Depression-era budgets, when most farmers were still paying off equipment purchased in better times. Most test units were recalled and scrapped to recover materials. 3 are confirmed to exist today, one at a private collection in Iowa where it's maintained in running condition, one at the Smithsonian Storage Facility awaiting restoration, and one that occasionally appears at antique shows in Kansas, drawing crowds of admirers who understand they're seeing technology that was too good for its own time. The number 9 proved that even in the 30s, John Deere was thinking decades ahead, building machines for a future they believed would eventually arrive. Number 8, the 1935 case model, RC self-propelled experimental. In 1935, most harvesters were pulled by horses or tractors, making them cumbersome, slow, and requiring multiple operators to manage both tractor and harvester. Case saw the future and built something nobody else dared, a self-propelled harvester with an integrated traction system that combined everything into one revolutionary machine. The Model RC Experimental was never cataloged, never advertised, and never officially sold through dealers, but it changed everything about how engineers thought about harvesting equipment. Case engineers mounted a complete threshing mechanism onto a 4-wheel chassis powered by its own engine, eliminating the need for a separate tractor and the coordination problems that came with it. The power plant was a Case straight 6, producing 51 horsepower from 339 cubic inches, breathing through a single updraft carburetor and cooled by a front-mounted radiator the size of a barn door. This engine drove both the threshing components and the rear wheels through a unique split-power transmission that allocated torque based on instantaneous load requirements. Under heavy threshing conditions, when thick crops entered the cylinder, more power automatically went to the threshing mechanism. On soft ground or slopes where traction was critical, the system redirected power to the wheels to prevent slippage. It was brilliant engineering wrapped in 1930s sheet metal, decades before computers could manage such systems. The cutting header spanned 13 feet and used a sickle bar design with hardened blades that could slice through lodged grain without clogging, a common problem that stopped other machines dead. Behind the header, grain traveled up a canvas conveyor into a rasp bar cylinder, spinning at 850 RPM, aggressive enough to thresh cleanly, but controlled enough to prevent kernel damage. The separation system used 4 straw walkers, each 6 feet long, and a dual-screen cleaning chute that used wind and gravity to remove chaff, delivering clean grain into a hopper with 180 bushel capacity. The operator sat in an elevated steel seat with a steering wheel, clutch pedal, and throttle, just like driving a truck, which made training easier for younger farmers who'd never operated complex machinery before, but understood automotive controls. The steering system used automotive-style kingpins and tie rods, far more responsive than the clumsy steering mechanisms on pulled combines that required constant correction. Case built approximately 15 units for field testing across the Midwest in 1935 and 1936, placing them with progressive farmers who provided detailed feedback. The machines worked beautifully, operators reporting they could harvest more acres with less fatigue compared to managing separate tractors and combines. But the machines cost nearly twice what a traditional pull-type combine and tractor together would cost. Economics that made no sense when farmers were losing land to foreclosure. Case stored the prototypes in various facilities, planning to revisit the concept when times improved and farmers had money again. Most were scrapped during the metal drives of World War II, when every pound of steel was needed for tanks, ships, and aircraft that would win the war. Only 2 survived, one in a case museum in Wisconsin where it's displayed as a forward-thinking achievement, and another in private hands in South Dakota, carefully preserved by a family who understood they owned a piece of harvesting history that changed the industry forever. The Model RC proved that self-propelled harvesting was not only possible, but practical in the 30s, even if the market wasn't ready to embrace the future. Number 7. The 1939 Massey Harris No. 21 pull-type with auxiliary engine. Massey Harris built their reputation on reliable, no-nonsense farm equipment that worked day after day without drama. But the No. 21 was their moonshot, a harvester so advanced it seemed like science fiction on farms, still using mules for cultivation. Released in the final months of 1939, just as war clouds gathered over Europe and the world prepared for conflict, this machine featured something almost no other harvester had: an auxiliary engine dedicated solely to powering the threshing mechanism independently of the tractor. Most combines ran everything off the tractor's power takeoff, or PTO, which meant if the tractor bogged down in soft spots or heavy crops, threshing slowed or stopped entirely, reducing efficiency and damaging grain quality. The Massey Harris No. 21 eliminated that problem with elegant engineering. The main engine was a Chrysler Industrial 6-cylinder, producing 48 horsepower from 218 cubic inches, mounted on the harvester itself and driving only the threshing, separation, and cleaning components through dedicated chains and belts. The tractor pulling the machine only provided propulsion, allowing it to focus entirely on maintaining ground speed. This separation of duties meant consistent threshing speed regardless of ground conditions and allowed farmers to use smaller, less expensive tractors that consumed less fuel. The cutting platform measured 12 feet wide and featured a finger reel with adjustable speed controlled from the operator's station, perfect for working with tangled or wind-damaged crops that required gentle handling. Grain flowed smoothly into a rasp bar cylinder 8 inches in diameter and 32 inches long, spinning at a brutal 920 RPM to ensure complete threshing even with difficult crops like damp wheat or tangled oats. 4 straw walkers, each equipped with adjustable agitation fingers, separated grain from chaff with mechanical precision, and a triple-screen cleaning system removed remaining debris before grain entered the 150-bushel tank. The entire machine weighed 6,200 pounds dry, carefully balanced to prevent excessive tongue weight that would strain smaller tractors. Massey Harris painted it in their iconic red and straw yellow livery, colors that became synonymous with quality across the prairies and became a source of pride for farmers who owned Massey equipment. What made the No. 21 truly rare wasn't just the auxiliary engine design, it was the tragic timing of its introduction. Production began in late 1939 and continued into early 1940, but by summer of that year, Massey Harris factories were retooling for war production, building military vehicles and equipment instead of farm machinery. Fewer than 200 units reached North American farms before production ceased entirely and wouldn't resume until after the war. Most saw brutal service through the war years when replacement parts were unobtainable and maintenance was deferred because every able-bodied mechanic had gone overseas to fight. Survivors are extraordinarily rare today. Perhaps 8 to 10 examples exist worldwide, scattered across private collections and small agricultural museums, and they're considered holy grails among Massey Harris collectors who understand the No. 21 represented the absolute peak of pre-war engineering before everything changed forever and the company shifted focus to survival rather than innovation. Number 6. The 1933 Oliver Hartpar row crop combine prototype. Row crop farming in the 1930s meant corn primarily, and harvesting corn meant either backbreaking hand labor that left families exhausted or specialized equipment nobody could afford during the Depression's darkest years. Oliver Hartpar saw an opportunity in this problem and engineered something radical, a combine designed specifically for row crops, capable of harvesting corn, sorghum, and soybeans without time-consuming reconfiguration between crops. The 1933 prototype was years ahead of its time. In both concept and execution, Oliver mounted the machine on a narrow frame that straddled 2 rows simultaneously, with independent adjustable headers that could adapt to row spacing, from 30 inches to 44 inches, accommodating regional variations. This flexibility was critical because row spacing varied dramatically by region and farmer preference, with some areas planting narrow rows for maximum population, while others used wider spacing for cultivation access. Power came from an Oliver 4-cylinder engine, displacing 230 cubic inches and producing 34 horsepower at 1,200 RPM, adequate for the relatively light loads of row crop harvesting. The engine drove a picking mechanism that grabbed stalks gently, stripped ears or pods without damage, and fed them into a husking bed lined with spring steel fingers that removed husks through friction rather than brute force. After husking, grain entered a small threshing cylinder specifically designed for corn and soybeans that broke kernels free from cobs or pods, then dropped material into a gravity-fed cleaning system that used airflow to separate grain from debris. Clean grain collected in an 80-bushel hopper, while cobs and husks were blown out the rear to mulch back into the soil. The entire process happened continuously as the machine crept forward at 1.5 miles per hour, steady progress that added up to impressive daily totals. What made this Oliver truly special was the revolutionary picking mechanism that set it apart from brutal competitors. Traditional corn pickers of the era used aggressive snapping rolls that grabbed stalks violently, often breaking them and losing ears that fell to the ground unharvested. Oliver's design used a gentler gathering chain system with rubber-coated fingers that guided stalks into the machine without the violent jerking that caused losses, reducing ear loss to under 3% in field tests. This difference meant money in the farmer's pocket at a time when every bushel mattered desperately. The operator sat high on an open platform with full visibility of both row units below, controlling ground speed, header height, and reel speed with hand levers positioned for easy reach during the long harvest days. The seat was mounted on springs to absorb shock from rough ground, a small comfort that made 12-hour days slightly more bearable when comfort wasn't a priority for most farm equipment. Oliver built approximately 30 prototypes in 1933 and tested them extensively on farms throughout Iowa, Illinois, and Indiana, the heart of American corn country where machines face the toughest conditions. Results were impressive by any measure. The machine could harvest 15 acres per day with a single operator, compared to perhaps 2 acres with hand labor that required an entire crew. But the Depression crushed demand completely. Farmers couldn't justify the costs when labor was cheap and desperate men would work dawn to dusk for $1 and a hot meal, sometimes working just for food alone. Oliver shelved the design reluctantly and returned to manufacturing simpler, less expensive equipment that Depression-era farmers could actually afford with their devastated finances. Most prototypes were dismantled or abandoned in dealer yards where they sat rusting as silent monuments to ideas ahead of their time. Today, only 5 are confirmed to exist anywhere in the world, and 2 of those are incomplete, missing critical components that were scavenged decades ago to repair other equipment when parts became scarce. The Oliver Hart Parr row crop combine proved that specialized harvesting equipment was not only viable, but superior in the 30s. But the market had to wait for better economic times and higher labor costs before the concept made financial sense to farmers struggling just to survive. Number 5, the 1938 Minneapolis Moline Model 69 Hillside Combine. Harvesting on slopes wasn't just difficult in the 1930s. It was genuinely dangerous work that injured operators and damaged expensive equipment. Combines tilted at alarming angles, grain slid to one side of the cleaning shoe, rendering it ineffective, and operators fought constantly to maintain control while fear gnawed at them. Minneapolis Moline decided to solve this problem with pure engineering genius instead of accepting suffering as inevitable. The Model 69 Hillside Combine, introduced in 1938, featured a self-leveling mechanism that kept the threshing and cleaning components horizontal, even when the chassis tilted up to 18 degrees, angles that would paralyze conventional machines. This was achieved through a complex system of pivots, pendulums, and precisely calculated counterweights that responded automatically to terrain changes without any input from the operator. No electronics, no hydraulics, no complicated controls, just mechanical genius born from understanding physics and applying it brilliantly to farm equipment that faced brutal conditions. The machine used a Minneapolis Moline 4-cylinder engine, producing 39 horsepower from 263 cubic inches, mounted rigidly to the leveling frame so it remained upright regardless of chassis angle, ensuring consistent power delivery. The cutting header measured 11 feet wide, smaller than prairie machines built for flat country, but absolutely perfect for the rolling terrain it was designed to conquer without compromise. Behind the header, grain entered a rasp bar cylinder 9 inches in diameter, spinning at 800 RPM, then passed over 5 straw walkers before reaching the cleaning shoe that made the machine revolutionary. The shoe was the absolute heart of the leveling system, mounted on trunnions that allowed it to swing freely like a pendulum, maintaining horizontal orientation through gravity and counterweight regardless of how the chassis tilted. This meant consistent cleaning performance on slopes that would have paralyzed conventional combines completely. The grain tank held 130 bushels and featured an offset unloading auger positioned carefully to prevent tank weight from disrupting the delicate leveling balance that made everything work. Minneapolis Moline painted these machines in their distinctive prairie gold color scheme with red accents that caught the eye, and they were absolutely stunning to watch work in the field, seemingly defying physics as they crawled across hillsides with the threshing components perfectly level while the wheels followed the slope below. Farmers who witnessed the Model 69 working for the first time often stopped whatever they were doing to watch in complete amazement, unable to believe what they were seeing with their own eyes. The Model 69 was purpose-built for the Palouse region of Washington and Idaho, where wheat fields roll across dramatic terrain that rises and falls like frozen ocean waves, terrain that defeated conventional equipment. It was never intended as a mass-market machine for flat prairie farms, and Minneapolis Moline produced fewer than 120 units between 1938 and 1940, before war production halted civilian manufacturing. Most stayed in the Pacific Northwest where they were needed most and were worked hard until they simply wore out completely, their leveling mechanisms finally succumbing to decades of constant adjustment and stress that no machine could withstand forever. Fewer than 6 examples survive today anywhere in the world, and all are in museums or serious private collections where they're preserved as stunning examples of Depression-era innovation at its absolute finest, proof that desperate times produce brilliant solutions. Number 4. The 1936 Advanced Roomley Thresher-Baler Combination Unit. Imagine a machine that could harvest grain and bale straw simultaneously in a single pass, eliminating an entire second trip through the field and cutting labor requirements dramatically. That's exactly what Advanced Roomley attempted with their 1936 experimental thresher-baler combination unit. And it was either brilliant innovation or complete insanity depending on who you asked at the time. Advanced Roomley, already struggling financially during the Depression's merciless middle years, decided to make one last ambitious push before merger talks with Allis-Chalmers finalized, and the company lost its independence forever. They took a standard Model E pull-type combine and added a complete baling mechanism behind the straw walkers, creating a machine that defied conventional thinking. As grain separated from straw and dropped into the hopper, straw continued rearward into a compression chamber where hydraulic rams squeezed it into dense rectangular bales. Twine applicators tied each bale automatically, and a kicker mechanism dropped finished bales onto the ground in neat rows for later collection. The system required enormous power to run both operations simultaneously. A Waukesha 6-cylinder engine producing 57 horsepower from 382 cubic inches, driving both threshing and baling through a nightmarishly complex system of belts, chains, and gearboxes that mechanics viewed with equal parts admiration and dread. The cutting header was a modest 10 feet wide to keep power requirements manageable, and the entire contraption weighed over 7,000 pounds empty, becoming even heavier as the grain tank filled during operation. Fuel consumption was absolutely brutal, approximately 2 gallons per acre, triple what a conventional combine required for the same work. But the labor savings were undeniable and impressive. One operator could harvest and bale simultaneously, eliminating the need for a second machine and crew that would normally follow days later to bale the straw windows, cutting labor costs dramatically at a time when every penny mattered. Advanced Roomley tested roughly 12 units during the 1936 harvest season across Kansas and Oklahoma, where straw had real value as livestock feed and bedding, rather than being a waste product to burn. The machines worked, but barely, and with constant attention. The baling mechanism jammed frequently, especially in damp or green straw that didn't compress properly. Hydraulic systems leaked constantly, leaving trails of expensive fluid across fields and requiring daily refilling. Twine applicators misfired regularly, producing half-tied bales that fell apart during handling and wasted time. And the crushing complexity meant constant maintenance. Farmers reported spending more time repairing the combination unit than actually harvesting with it, defeating the labor-saving purpose. Still, farmers who mastered the combination unit through persistence and mechanical skill swore by it absolutely, finishing harvest in half the usual time and capturing straw value that would otherwise have been lost to weather or fire. Advanced Rumeli planned enthusiastically to refine the design for 1937 production, addressing the reliability issues and simplifying the baling mechanism to reduce maintenance. But the company merger halted development permanently and completely. Prototypes were scattered among dealers across the plains and disappeared into farmyards, where most were eventually scrapped. Only 2 are known to survive today. One, incomplete at the Smithsonian storage facility, missing its baling mechanism entirely, and one mostly complete in a private collection in Kansas, carefully preserved by an owner who recognized its significance as a bold experiment. The Thresher-Baller combination represented the kind of ambitious, almost desperate innovation that characterized the Depression era. Ideas so bold they bordered on reckless, born from necessity and executed with whatever resources remained when bankruptcy loomed, and dreams died daily. Number 3, the 1931 McCormick Deering 1520. Experimental, self-propelled. International Harvester owned the farm equipment market completely in the early 1930s, dominating sales and setting industry standards. But they weren't content with mere dominance. They wanted revolution that would cement their leadership for generations. In 1931, while competitors struggled desperately to survive the Depression's early stages, and some went bankrupt, International secretly developed a self-propelled harvester so advanced it wouldn't be matched for over a decade by any competitor. The McCormick Deering 1520 experimental combined a pull-type harvester with a traction unit in a single integrated machine that reimagined harvesting completely. Power came from a massive International 4-cylinder engine displacing 421 cubic inches and producing 63 horsepower at 900 RPM. Enormous output for 1931, when most tractors produced half that power. This engine drove everything through a clever split transmission that allowed independent speed control for ground travel and threshing operations, a feature that gave operators unprecedented flexibility. The operator could increase ground speed without changing cylinder RPM when moving through thin crops, or slow down dramatically in heavy crops without affecting threshing efficiency that determined grain quality. This flexibility meant consistent grain quality and maximum productivity across wildly varying field conditions that changed by the hour. The cutting header measured 15 feet wide, among the absolute largest of the era, and featured a draper canvas system that was more reliable than the complex auger systems used by competitors who fought constant jamming problems. Behind the header, grain entered a massive rasp bar cylinder 10 inches in diameter and 40 inches long, the largest threshing cylinder mounted on any combine of the decade anywhere in the world. 6 straw walkers ensured complete separation without wasting grain, and a 4-screen cleaning chute delivered spotless grain into a 200-bushel hopper. Extraordinary capacity for the time that reduced dumping stops. What made the 1520 truly revolutionary, beyond its impressive specifications, was the operator's station that redefined comfort. Instead of an open platform that exposed operators to dust, heat, and weather, International built an enclosed steel cab with windows on 3 sides, providing visibility, a padded seat with adjustable height for operator comfort, foot pedals for clutch and brake that felt natural, and a steering wheel that controlled articulated front wheels with automotive precision. It was genuinely the first harvester cab designed primarily for comfort rather than just function, acknowledging that operators spent 12 to 16 hours per day in the seat during harvest season when every daylight hour mattered. The machine sat on 4 large pneumatic tires, another bold innovation in an era when steel wheels still dominated farm fields and rubber was considered experimental. These tires reduced soil compaction that hurt future crops and improved flotation in soft conditions, allowing the machine to work fields that would bog down wheeled competitors immediately. International painted the experimental units in their traditional harvester red with cream-colored wheels that looked striking, and they looked like farm equipment from the future, sleek, purposeful, and genuinely intimidating in their advanced appearance. The company built 23 prototypes in 1931 and tested them extensively across the Midwest and Great Plains, gathering data and operator feedback. Performance exceeded even optimistic expectations consistently. The machines could harvest 20 to 25 acres per day, double the capacity of conventional pull-type combines with just a single operator instead of the two-man crews competitors required. But the timing was absolutely catastrophic for commercial success. By late 1931, the Depression had devastated rural America beyond recognition. Banks were failing weekly, crop prices had collapsed to levels that didn't cover seed costs, and farmers were losing land to foreclosure at unprecedented rates. Nobody could afford experimental equipment that cost as much as a house when most couldn't afford food. International shelved the project sadly, planning to revisit it when economic conditions improved and farm income returned. That didn't happen until after World War II ended, and prosperity finally returned, when the same basic concepts finally reached production as the famous international self-propelled models that dominated the 50s. The 1931 prototypes were stored carefully at various international facilities, and most were scrapped during wartime metal drives, when every pound of steel was desperately needed for the war effort. Only 4 survive today, 2 at company museums where they're displayed with pride, 1 at the Smithsonian representing agricultural innovation, and 1 in a private collection in Illinois that occasionally appears at antique shows, drawing massive crowds of people who simply can't believe they're seeing such advanced technology from 1931. Number 2, the 1937 Caterpillar 28 Hillside Harvester. Caterpillar made their fortune building crawlers for construction and heavy earth-moving work. But in 1937, they shocked the agricultural world completely by building what many experts consider the most capable hillside harvester ever created anywhere, the Caterpillar 28. Hillside Harvester was designed specifically for terrain so steep and challenging that conventional wheeled machines simply couldn't function safely or effectively. Built on a tracked chassis derived directly from Caterpillar's proven crawler tractor technology, this machine could harvest on slopes up to 25 degrees, angles that would tip a wheeled combine onto its side and kill the operator. The track design provided extraordinary stability and flotation that wheeled machines couldn't match, distributing weight across a much larger surface area and preventing the machine from sinking in soft ground that trapped competitors. Power came from a Caterpillar diesel engine, making this one of the very first diesel-powered harvesters ever built anywhere in the world. The engine displaced 441 cubic inches and produced 58 horsepower at 1,400 RPM, running on fuel oil that cost half as much as gasoline and lasted 3 times longer between maintenance intervals when properly maintained. In an era when diesel was still exotic and somewhat mysterious in agricultural applications, this was genuinely bold engineering that required convincing skeptical farmers. The technology was reliable and wouldn't leave them stranded. The cutting header measured 12 feet wide and was mounted on a leveling system even more sophisticated than the impressive Minneapolis Moline design that preceded it. The header could tilt independently from the main chassis, maintaining proper cutting angle, even when the tracks climbed across dramatic contours that varied constantly. Behind the header, grain flowed smoothly into a massive rasp bar cylinder, 11 inches in diameter, driven by roller chains and spinning at 7,150 RPM to ensure complete threshing. 7 straw walkers provided thorough separation, feeding into a triple-screen cleaning chute that stayed level through an ingenious pendulum-mounted gimbal system that responded instantly to terrain changes. Clean grain collected in a 160-bushel hopper with a hydraulic unloading auger that could swing 180 degrees, allowing the operator to dump grain uphill or downhill as needed without repositioning the entire machine. The operator's station was fully enclosed in welded steel that provided protection from weather and flying debris, with a swivel seat that allowed the operator to face forward or rearward depending on which operation demanded attention. Forward-facing position was used during cutting operations, while rearward position allowed the operator to monitor grain flow and tank filling without turning around constantly. Caterpillar painted these impressive machines in their signature highway yellow, that had become famous on construction sites, making them visible for miles across the rolling wheat fields of the Palouse and the steep Sierra foothills where they worked. The 28 was never intended for flat prairie farms, where conventional equipment worked fine. It was highly specialized equipment for specialized terrain, and Caterpillar marketed it exclusively to regions where topography made conventional harvesting impossible or genuinely dangerous to operators. Between 1937 and 1939, Caterpillar produced approximately 75 units total, all hand-built at their Peoria facility and shipped west by rail to dealers serving hillside regions. The machines were expensive, nearly 3 times the cost of a conventional combine. But for farmers working steep hillsides where alternatives didn't exist, they were the only option that worked reliably and kept operators safe. Most 28s stayed in service for decades, working through World War II and well into the 1950s, before finally wearing out from the brutal conditions they faced daily. Today, fewer than 5 complete examples are known to exist anywhere, and they're considered the ultimate acquisition among serious Caterpillar collectors who understand these machines represented everything Caterpillar knew about tracked machinery applied brilliantly to agriculture. Number 1. The 1932 Holt combined the harvester and experimental leveling system. Before Caterpillar existed as the company we know today, there was Holt Manufacturing Company, pioneers who invented the tracked tractor, and in 1932, just 1 year after merging with Best to form Caterpillar, they built something that disappeared almost completely from history, but absolutely deserves to be remembered as the rarest and most revolutionary harvester of the entire decade. The Holt combined harvester with experimental leveling system was a tracked machine that anticipated self-propelled, self-leveling combine technology by over 15 years, technology that wouldn't become mainstream until the 1950s. Only one prototype was ever completed, making it unique, and its fate remained completely unknown for decades until fragments were discovered in a California barn in the 1990s by a researcher who recognized their significance. The machine was built on a tracked undercarriage derived from Holt's famous crawler tractor design, with individual track assemblies that could articulate independently from each other. This allowed the chassis to traverse wildly uneven terrain while keeping the harvesting mechanism level and functional. But Holt went much further than simple articulation. They mounted the entire threshing and cleaning system on a 3-axis gimbal platform that stayed perfectly horizontal regardless of chassis position beneath it. Gyroscopic stabilizers, powered by a dedicated secondary engine, made constant micro-adjustments to maintain level orientation automatically without operator input. This was mechanical engineering decades ahead of its time, using principles in physics that wouldn't become common in agriculture until GPS and electronic controls emerged in the 1990s and changed everything. The primary power plant was a Holt 6-cylinder engine, displacing 537 cubic inches and producing 78 horsepower at 1100 RPM, the absolute most powerful harvester engine of the 1930s anywhere in America. This engine drove both the tracks and the threshing mechanism through a complex power split transmission that allocated power dynamically based on instantaneous load conditions and demands. The cutting header spanned 16 feet, the widest of any 30s harvester by a significant margin, and used a draper system with 3 separate canvas belts that could adjust speed independently to handle varying crop density that changed constantly across fields. Behind the header, grain entered a cylinder assembly unlike anything else of the era, 2 counter-rotating cylinders that threshed grain between them, reducing kernel damage while dramatically improving separation efficiency compared to single-cylinder designs. 8 straw walkers and a 5-screen cleaning chute processed material thoroughly before grain entered a 250-bushel hopper, capacity that wouldn't be exceeded until the 1950s when farms grew larger. The operator sat in an enclosed cab with panoramic visibility through large windows, controlling the machine with a steering wheel, throttle lever, and an impressive array of switches and levers that adjusted every parameter from cutting height to cylinder speed to track tension. Holt painted the prototype in their traditional green and cream livery that dated back decades. Though photographs from the era show the paint was already fading and the machine showed obvious signs of hard use during extensive testing. The Holt prototype was tested extensively during the 1932 harvest season across California's vast Central Valley and the wheat fields of eastern Washington, 2 regions that provided completely different challenges. Reports suggest the machine performed brilliantly, harvesting up to 30 acres per day on terrain where conventional combines struggled to manage 15. But the timing couldn't have been worse for commercial.